You're welcome to this lesson. Let us do this very interestingly, but then remember, I'm going to point few more things which I thought that in my explanation in one of the lessons I did on this was not good enough. The mistake I made was when I said that there is difference between effort and force. I want to correct that impression. What I mean is this, what I mean is this. Effort can also be a force because they are all expressed in Newton, but they are not gotten with the same formula. Like the formula you know about force, the general formula for force is given as m times acceleration due to gravity. You also know that we can also get force through this, which is also a frictional force. We can also get force through this. So there are different ways you can get force, and effort is one of them. So it's also a function, it's also a force because they are also can also be expressed in Newton per meter, Newton meter. Yeah, it can also be expressed in Newton. So, so what I'm going to do right now is, okay, looking at the question, a man pulls a box of mass 70 kg using an inclined plane of length 5 meters, whose height is 2.5 meters at a uniform speed. Mark this word, very important, uniform speed. If the frictional force is 100 Newton, draw all the forces acting on the box when it is in motion. Let's do that first. Let's draw all the forces acting on the box. All right, if this is an inclined plane, this is the horizontal ground, and this is the load, right? And this must have an angle. Okay, there is a force at this point because we have frictional force. There is a force that must pull this down. That force is given as mg sine theta. That is the first force. But there is another force which is a frictional force acting on this also. I will call it F. That is just a frictional force, remember? And there is an effort, a force which is pushing it up. I'm going to call it effort. So that is it. But this must have a weight which must act downward. And this is supposed to have a normal reaction which is acting at that point. And this should have a height onto which this will be pulled to. But this is 2.5 meters, which is the height of the plane. And from here all the way to this place is given as 5 meters because this is 5 meters in length of the plane. This is the height of the plane. Okay, so now that we have drawn all the forces acting, I think I have drawn all the forces acting. Okay, normally if I resolve this, I'm supposed to have mg cos theta. Let's see what we are going to use for the solution of this problem. Okay, all right, now I have done this, the first one. The next thing is, what is the effort, what is the minimum effort applied in pulling up the box? Look at where I said you need to note this statement. Whenever we say that a body has a uniform speed, it simply means that acceleration is 0. Now I'm going to find the resultant force. Resultant force here means, remember we have force E, force mg sine theta, and the frictional force. But provided this is moving up, according to the question, is moving up, it means that the effort minus mg sine theta minus the frictional force must be equal to ma. This is according to Newton's second law of motion, which is the resultant force is equal to mass times acceleration. But because they have a uniform speed, this acceleration is going to be 0. So everything here is 0. If mass times 0 is 0, therefore the effort is going to be given as mg sine theta plus frictional force. So this is the formula. So this is the formula for finding the effort in this case. But somebody will say, effort, is it not load over mechanical advantage? No, according to the problem, you analyze it. And that is what I've just done. So for this case, I'm going to have mass, m is for mass, which is 70, times g is acceleration due to gravity, which is given as this 10, all right? And 10 times sine theta. All right, I have a problem. How do I find the angle there? Remember, Sine theta is opposite over hypotenuse. So I'm going to say sine theta is 2.5 over 5, which is 2.5 divided 5, which is 0.5. So sine of what angle will give me 0.5? Theta must be 30 degrees. All right, so I have 30 degrees as the angle theta. So this is going to be 30 degrees plus, what is the frictional force? F is the frictional force. And the frictional force in this case, was I given any? Okay, I was given if the frictional force is 100 Newton. So I'm going to add 100. So at this point, I'm going to find sine 30 is 0.5. 0.5 times 70 is 35. 35 times 10 is 350. 350 plus 400 plus 100 is going to give me 450 Newton. So that is the effort needed to push the body onto the platform. You see how it is done? I did not cram the formula, just a principle of Newton's second law of motion. Okay. All right. The next question said mechanical advantage of the plane. This is I. II is mechanical advantage. Mechanical advantage is load over effort. Load is, I'm going to express the load in Newton. Remember, because load is 70. In Newton is going to be 70 times 10, which is going to be 700 divided by 450. This cancels this. I'm going to have 70 divided by 45, which is 1.56. No units. No unit, because that is it. Number 3, velocity ratio of the plane. III. Velocity ratio is given as 1 all over sine theta. Or I can say distance moved by effort all over distance moved by load. Right? Can also give me that, but in this case I'm going to have 1 over 0.5, which is 2. Supposed to be 1 divided by 0.5 is 2. Yeah. So velocity ratio is given as 2. Then what else I'm looking for? Efficiency of the machine. Efficiency is given as mechanical advantage all over velocity ratio times 100% over 1, which is going to be 1.56 all over 2 times 100 is going to be equal to 1.56 divided 2 times 100, which is 78%. So mechanical advantage is 78%. The next question there say energy lost in the system. Energy lost in the system must be, there are 2 energy here. There are 2 work done. Because energy and work are the same thing. So at this point, the energy lost is going, I'm going to have 2 kinds of work done. Because I have a height, there is work done by carrying this load from the ground to this platform. And there is another work done by moving in this direction, because whenever there is distance and load and the force applied, then that means work is done there, because work is defined as force times distance. But there are 2 kinds of work. The work that went through this part when the effort is there, and the work that goes there through the load. This is what load is doing, and this is what effort is doing. So I'm going to find what I will do right now in order not to blow this thing out of proportion. What I'm going to do is find the 2 work and subtract them, because that is loss. When we talk about loss, we are talking about differentiation. We are talking about subtraction. All right, so that is number 5. I'm going to have effort times distance. So this is E times 5. Effort is 450 times 5, which is, yes, let's just do it, 450 times 5, 2250 joule. That is the work. There's another work done this way, and I'm using the load. Remember, load, effort. So load in this case is going to be have load times 2.5, which is, load is 700 times 2.5, which is 700 times 2.5, which is 1750. Therefore, I'm going to subtract them. So energy lost is going to be 2250 minus 1750. So this is going to be 2250 minus 1750, which is 500 joules. So the energy lost is 500 joules. Okay, I think the next thing is work output of the man. The work output is whatever the load has done. Anything that has to do with input is what the effort, because effort is you putting your effort, that is the input. Then output is what has happened, which is what the load has done. So that is going to be work output is going to be load times distance moved by load, which is 1750 joules. Just the load is 700 newton times the height it moved. All right, so the next thing is total power developed by the man if the total time to raise the box is 50 newton. At this point, total power is work done per time taken. Work done, and work done cannot be work input. Work done must be work output all over time taken. So I'm going to say that power, which is VII, yes, this is VII. VII is going to be, power is going to be work output divided by time taken, which is going to be work output. In this case, I called the output is what the load did, which is 1750. 1750 all over the time taken is 50. They'll cancel. This is 175 divided by 5, which is, am I sure this is correct? 35 joules, 35 watts. This is correct. That power must be correct. I'm not going to overthink this, because the main thing is to do work, because this is a machine. The main thing is for it to do work, and for it to do work is not your effort. No, it is the output. It's not the input. So please, this is the best thing to handle it. Thank you for being part of this lesson. Remember to hit the subscribe button, like this video, share it, and have a nice time.